Good day, and we meet again, grade 11s and 10s, and welcome to this video on the continuation of what we did in the first video. Oh, my bad. Of what we did in the first video, which was redox reaction, redox reactions. So I looked at redox reactions in the first video. Just gonna have a continuation on this one. Okay. Um, By the way, please do not watch this video if you have not watched the first one, because the first one is very fundamental in order to comprehend what is going to be said in this one, right? But yeah, okay, let's get into it. So today I just want us to have a little talk on what we call oxidation numbers. So this is very important information that you must know. Very important information that you must know about oxidation numbers and what rules have been set for you guys to follow in a typical exam. You know, these are very fundamental rules that once you follow these rules, trust me, you're gonna have a smooth journey in this topic. Right. So so there's certain rules under oxidation numbers that must be followed, rules that are very, very important to guarantee your success. I'm gonna make this a bit less thicker in redox reactions. Yes, that's fine. All right, so what are those rules? So there are three things that you must know about oxidation numbers. Those things will basically help you keep track of how it works with electrons during a certain chemical reaction, that being a redox reaction, and how certain oxidation numbers are basically assigned to respective elements, right? So think about oxidation numbers as the valency of an element, right? So that is if you have a certain, well, say oxygen, and oxygen is in group 6, and we all know that means it has 6 valence electrons. But what is the charge on oxygen? A 2 minus charge. The charge of an atom or a certain element is equal to its oxidation number. So that's the first rule. So we start there. We say the charge of an atom, the charge of an element in certain groups, say group 1, group 2, and group 3, right? So the charge of an element in group 1 and group 1, 2, and 3 is equal to the oxidation number. It's then equal to the oxidation number of that particular element. It's equal to the oxidation number of that particular element. So what does this basically mean? This basically means that if you have a certain element, right? So if you have a certain element in group 1, 2, or 3, right? Just these three, very, very important. It's just these three groups. Because when we talk about group 5, 6, 7, obviously not 8, right? So if you talk about group 5, 6, and 7, those actually change depending on what it reacts with, what it's bonded to, and all of that, including hydrogen as well. So hydrogen is the only one in group 1 that does not have a charge that's equal to it. It does, but it changes depending on what it is actually when you bond it with a certain metal, if I recall correctly. Then it changes, right? But we'll get to that. We'll actually get to that. Cool. So what I mean when I say the charge of an element in group 1, 2, and 3 is equal to the oxidation number of that element. So if you want to know, say given an element like potassium, so given potassium and you're asked what is the oxidation number of potassium, what do you know? You know that potassium is in group 1, that means it has a positive 1 charge. That basically tells you that the oxidation number of potassium, so I'm going to write every oxidation number in a different color. Let's make that pink. We're using a lot of pink. Let's make that orange. So I'm going to write the oxidation number in orange. So the charge, which is positive 1, is equal to the oxidation number, which would then be 1. Well, that's if it's in an atom. Remember, please do not forget that. That is if it is in a certain not atom, but a certain compound. So that is, if you bond it with something else, then this rule would basically apply, right? So that is, we know that potassium on its own it's just 0, but when it's bonded to something else, then it should have an oxidation number of 1. The oxidation number is equal to the charge. Very, very important, right? Yes, so if you look at another element, say magnesium. Magnesium has a charge of 2 plus. When it's bonded to another element, remember just magnesium is 0, but when it's magnesium bonded to something, when magnesium forms a compound with something else, we then say the charge of magnesium, the oxidation number of magnesium is 2, just a positive 2. If you look at something like, just trying to use one that has a negative charge, say nitrogen, or rather say fluorine. Fluorine has a charge of -1, right? It changes, we're going to get to that, but when it's forming a compound with something else, then it has a oxidation number of -1. It changes. So let me just not use this one, because now you're actually going to think it's always like that. It is like that, but it depends. There are certain conditions, or rather exceptions, that must be met. Well, that actually force that to actually change. Right. In fact, let's just get into that right now. So when we say that something, so I hope you actually find what the first rule. Now the second rule basically says, it goes into this one. Now the second rule basically says that fluorine, right? Now join with me. In fact, let's start here. Oxygen, right? So oxygen, what oxygen basically does, so let's just remove this. So oxygen basically does, we all know that oxygen is in group 6 and has a -2 charge. So it has a charge of -2. But it changes when it is in a peroxide. When it is in a peroxide. So it changes when it is in a peroxide. So what does that mean? So when I say it changes when it is in a peroxide, what does it change to? So when it's in a peroxide, it changes to, so oxygen has an oxidation number of a, sorry, just trying to remember. So when it's in a peroxide, it has an oxidation number of -1. Right, so notice how it changed. So what is a peroxide? A peroxide, for example, would be hydrogen peroxide. That would be H2O2. So when you have a situation like this one, then the oxidation number of oxygen will not be a -2. No, it will actually be a -1. That is if it is in a peroxide. That could also be any other peroxide, say sodium peroxide, so that's Na2. If it's like this, then it will not have a -2, but it will have a -1, right? So that's very important information. Okay, so these are rules that you must make sure that you do not forget. Very, very important rules. Okay. Oh, and also it changes, right? Also when it's bonded to a fluorine, right? So also when bonded to a fluorine, So when it's bonded to a fluorine, the oxidation number of oxygen then becomes a +2. So this is very important information. You must never forget this. So that is why I actually try to abstain from using oxygen, because it actually changes. It does not stay the same all the time. Okay, so when you get to the third one basically says, right, so the third one says, wait, isn't that the one that I had mentioned? Yes, so the one that I had mentioned in the previous video was that every pure element has an oxidation number of 0. Has an oxidation number of 0. So every pure element has an oxidation number equal to 0. 0. That is, if you have a certain substance like arsenic. Arsenic has an oxidation number of 0. Why? Because it's a pure element. If you look at bromine will have an oxidation number of 0 because it's a pure element. If you look at boron will have an oxidation number of 0 because it's a pure element. Lithium, 0 because it's a pure element. Rubidium, 0 because it's an. I really hope you guys are getting this. So for as long as it's a pure element, the oxidation number is 0. Right? How do you identify a pure element? It's just that in a reaction, it would be that particular element, say bromine, plus something else. So it's not HBr or something Br, it's just bromine. Then we say it has an oxidation number of 0. Okay, so that's very, very important. Cleos. And then we get to the fourth one. So this one basically tells you, so what they mean is that we all know that hydrogen is in group 1, and we say that the charge is equal to the oxidation number. Therefore the charge of oxygen is positive 1. Thus the oxidation number is also a positive 1. But it changes when bonded to a metal. When bonded to a certain metal. Changes when bonded to a metal. So when you bond it to a metal, it actually changes. That is, the oxidation number moves, does not, so the oxidation number, I really don't know why I have here, ox and O. So initially we know that the oxidation number of hydrogen is positive 1, but it actually changes when it's bonded to a metal. So what does it become? It becomes a negative 1. So when it's bonded to a metal, it becomes a negative 1. Now why is that? So think of a certain metal like sodium hydride. Sodium hydride, right? So think about it. Sodium has a charge of positive 1. So Na plus, and hydrogen has a charge of positive 1. Now you wouldn't be able to bring these two guys together. You wouldn't be able to bring them together if they both have positive charges. So what would you have to do? We all know, like I said in one of the rules, that the charge of any element in group 1, 2, and 3 does not change. It stays as that, and it's equal to the oxidation number. So we know that this must stay as a positive 1. But something must happen to H so that we can bring these two guys together and form that. Thus, the only thing that can happen is if H becomes a negative 1, so that these can cancel, and then they both can form this guy. So every time it's bonded to a certain metal, it has to change its oxidation number. It will not be a positive 1, it will be a negative 1. Right, so that's what it basically means. And then if you look at a certain another one, so this other one basically tells you about monoatomic ions, and yeah, just monoatomic ions. So we say that the oxidation of a monoatomic ion, I feel like this one is basically what I meant here. A monoatomic ion, yes. So the oxidation, so it basically relates to number 1 in a way. So where you say that the monoatomic ion has an oxidation number equal to the charge, has the oxidation number equal to the charge. Oxidation number equal to the charge. I think I've mentioned this. Well, it somehow relates to number 1. So that is, if I have a certain zinc 2 plus, that means the charge of zinc will then be, the oxidation number of zinc will be 2, positive 2 at that. If I have copper 2 plus, the oxidation number of copper will then be 2. That's all that it means, nothing hectic. So these are very important, guys. These are very important rules that you must never ever forget, ever. Okay. Then number 6 basically tells us about polyatomic ions. So if you have polyatomic ions, the polyatomic ion has the sum of the oxidation numbers, oxidation numbers equal to the charge. That is, if I have a certain polyatomic ion like the sulfate ion, SO4 2 minus, if I had to get a certain, so I'm required to get the oxidation number of sulfur, I wouldn't really know what it is. How would I get it? I know that since oxygen is not bonded to any peroxide or fluorine, it has a Yes, you know, it has the oxidation number of 2 minus because there's no fluorine, there's no peroxide. So that means that the oxidation number, so I'm just going to write oxidation number of sulfur plus the oxidation number of oxygen. Okay, I really need to try to use some different letter to denote. So oxidation number, I'm just going to put a hash sign, so please bear with me on this one. So hash just means oxidation. So the oxidation number of sulfur plus the oxidation number of oxygen equals to the charge, which is -2. It's the charge right there. That's what they mean when they say the sum of the oxidation number. Remember, sum means plus. So they're saying the sum of the oxidation numbers equals to the charge. The sum of the oxidation numbers equals to the charge. So in this particular case, how you would calculate is then you saying the subscript, by the way, plays a very pivotal role in this. The subscript is very important. The subscript of any atom becomes the coefficient of the oxidation number. That is, in this particular case, I would then say, I want to calculate the oxidation number of sulfur. Do I know the one of oxygen? Yes. For as long as it's not on a fluorine or a peroxide, we know that it's going to be a -2. But we use this subscript 4 as the coefficient. Therefore, it becomes 4, and that becomes S equals -2. So that becomes -8 plus 8, and that becomes a +6. So that is the oxidation number of sulfur in the sulfate ion. Right, so really hope you guys have that. Right, we're just about to finish with these, and I'm going to do a couple of examples just to get this understood. Right, so number 7. So this one basically looks at is the fact that if we're looking at so what can I say about this one? So if you're looking at a certain transition metal, so say iron, right? So we say that the transition metal oxidation number, so the transition metal oxidation number is indicated by what we call the stock notation. So the transition metal of oxygen is indicated by the stock notation of it. So don't have to worry about what that is. Just going to show you now. Okay, so what does that mean? That means if I have a certain element like fluorine, remember fluorine can be fluorine plus, 2 plus, 3 plus. So if I have fluorine 3 plus, I would have something like fluorine. Sorry, not fluorine. Why am I saying, oh my gosh, iron. Yes, iron 3 plus. So you would have something like this. Then we'll tell you 1, 2, 3. That's iron 3, right? So when they say iron 3, that means that's Fe 3 plus. That means this is also not just a charge, so it's a charge as well as the oxidation number. So if they have Fe 2, that means you're looking at Fe 2 plus, which is not just the charge, but is a charge and the oxidation number. So that's all that it basically entails. Right. Okay, this is a bit much to take in, I'm assuming, but really hope you guys got all of that. If you can just remember all of these rules, trust me, it's going to be a breeze, right? So I just want us to look at a couple of examples on how to basically apply all of these and calculate oxidation numbers of certain elements. So in an exam, you'll be required maybe given, what the example that I made of the sulfate ion. So they would give you a sulfate ion, they would say, calculate the oxidation number of sulfur. You must know how to do that. We're going to do a couple of examples just to put that to the test. So for number 1, we're going to look at how to calculate. So we'll be given a question and we have to determine the oxidation number of each substance, right? So say you're given iron chloride, FeCl3, right? So it's FeCl3, and you're basically required to calculate the oxidation number of this guy. Now, in this particular case, you need to apply the rules to this. So now we're going to say the oxidation number of Fe is, and the chlorine oxidation number is. Now we need to say, what is the oxidation number of fluorine, of iron? What do you guys think that is? We actually did it. And it actually tells you, this basically tells you that it was Fe3+, right? Because chlorine is just Cl minus. Great. So that just tells you that it was Fe3+, thus the oxidation number of hydrogen is, of iron is +3. Now what is the oxidation number of chlorine? Can we guess? It is a -1, but let's put it to the test. So I would have FeCl3. Oh, and by the way, same way that a polyatomic ion like SO4 2- has the sum of the individual oxidation numbers being equal to the charge, that is also true for a neutral compound. So FeCl3 is a neutral compound, that is, it has no charge, neither positive nor negative. Thus, the sum of these oxidation numbers is equal to 0. Forgot to mention that in one of the rules, but that's very important to also remember. Do not forget that. Okay, so now if you have to calculate the oxidation number of chlorine, we then say FeCl3, and that would be equal to 0. And then we know that the one for fluorine is a +3 plus, remember the subscript becomes, yes, the coefficient, so that's 3 times Cl, and that becomes 0, and 3 times Cl becomes a -3, and you solve for Cl, you get a -1. Right, so that's how you would typically do something like that. Right. Okay, so that is example 1 done. So if you look at example 2, say you're given a potassium permanganate, KMNO4. Right, so KMNO4. Now for starters, you guys must know that the permanganate ion is a polyatomic ion. That means it's something like this, MnO4 minus. Very, very important. Do not forget that. The permanganate ion is a polyatomic ion. Okay. So in this particular case, we say, so what is the oxidation number of potassium? Do we know it? Not really. Do we know the one of magnesium? Nope. Do we know the one of oxygen? Yes. What is oxygen? Because it's not bonded to a fluorine, and it's also not bonded to a certain peroxide, it's not in a peroxide, we then say the oxidation number is -2. And then for potassium, because it's a group 1 metal, remember the rules, we say that for as long as it's a metal in group 1, right, so group 1, 2, or 3, then that charge is equal to the oxidation number. So the charge of potassium is a +1, thus the oxidation number is a +1. Now we need to get the one for magnesium. So how do we do that? Same way we did with the FeCl3. So we go KMNO4, it's a neutral compound, therefore it's equal to 0. And then the one for potassium is just 1 plus manganese. I don't know why I keep saying magnesium. Sorry, that's manganese. Plus subscript, that means 4 times -2, which is equal to 0. That gives me manganese equals to, so that's a -1, I transpose the 1, that gives me a -8, when I transpose it gives you a +8, right? So what is a -8 plus an 8? So that gives me the oxidation number of manganese to be a +7. So that's your answer, +7. Hope you guys are really getting that. I'm gonna try to do a polyatomic ion after this. Okay, and then we have a third example. So just trying to get a polyatomic ion. Okay. Let's try the phosphate ion, right? So that's PO4 3-. Right. So do we know the oxidation number of phosphorus? No. Of oxygen? Yes. So the oxidation number of oxygen is -2 because there's no fluorine and there's no peroxide. So since it's a polyatomic ion, there is a certain charge. It's not a neutral compound like potassium permanganate or FeCl3. You'll then say PO4 3 minus equals to negative 3. Hope you guys are seeing this and how it actually works. So that's going to be equal to a negative 3. Thus, I'll then say potassium, which is what I want, plus subscript 4 times negative 2 equals to a negative 3. Thus, P will then be negative 3. That gives me a negative 8 plus 8. That will then give me an oxidation number of phosphorus as a positive 5. Right. Pretty fun, if you ask me. Okay, so if you look at the last one, just the final one, say we are given hydrogen sulfide, right? So if you had to determine this one, what is the one for hydrogen and what is the one for sulfur, right? Now think about it. Since hydrogen is not bonded to any metal, it stays as a positive 1. Yes. Now, what is the one for sulfur? We all know that sulfur is negative 2 because it's in group 6. But let's put it to the test. We can't just say it's negative 2 and just be happy about it. Now we know this is a neutral compound. Therefore, we have H2S equals to 0. And then there will then be the subscript, which is then 2 times positive 1 plus S, which is 0. And S will then be a negative 2. Okay, confidence booster. Okay. Right, I really hope that everything has been understood and we actually do follow on those rules. Very important. Notice how I've actually applied those rules to the examples that I was actually doing here. That is very important. Very important thing to not forget. But anyway, from me to you, I will then see you in the next video where we'll be discussing how to balance redox reactions. But let me love and leave you now, and I shall see you in the next video. Bye-bye.